All right, so section 5.2. So the difference between what we're doing today and what we did on Friday, what we just did on the board for these homework problems, is when we're verifying identities, we have a target. We have somewhere that we want to get. So we're using all the same tools, we're using all the same techniques. The only difference is we know where we're going. So I want to start by writing, so all of these examples, we're going to do a few examples. All of these examples we're verifying. So I'm going to say sine squared x minus 1 over sine squared x equals negative cotangent squared. So we want to verify that this is true. Now, several things about verifying identities. Cotangent squared x. We do not know that they are equal. So what that means is we can't work across the equal sign. We can't cross multiply, we can't add and subtract things from both sides because we don't know if they're equal. So I'm going to say we can't work across the equal sign. We have to show that they are equal. Sing. There we go. And the way that we're going to do this is we do some work on one side of the equation to show that we can get it to look like the other side of the equation. In general, there's not with verifying identities there are not a lot of hard and fast rules, but in general, you want to work on the complicated side. Because you have more to work with. There's more stuff there. And you also want to look for opportunities to use your Pythagorean identities. Look at the trig functions that are involved in where you want to get and try to write your other side in terms of those trig functions. So there's some general rules, but not hard and fast rules. And often for identities, there is more than one way to get where you want to go. All right, so for this one, I would say it's pretty clear to me that the left-hand side is more complicated. So I'm going to say let's work on the left. I already like the left-hand side because I have a sine squared x minus 1. So I'm going to remember that my Pythagorean identity, sine squared x plus cosine squared x equals 1. So sine squared x minus 1, I would have to subtract 1 from both sides and subtract cosine squared from both sides. So sine squared x minus 1 is negative cosine squared x. So I'm going to substitute that in. So I have negative cosine squared x over sine squared x. And isn't that what we wanted? Negative cosine squared over sine squared is negative cotangent squared. And that's where we're trying to get. So I showed that I could turn the left side into the right side. Yeah?
Would we have to take the cotangent squared and separate it out into negative cosine
No.
sine?
Mm-mm.
Okay.
Yeah.
What would happen if, like, you would sine squared x?
Then it would be this would have to be different on this side. It wouldn't be the same identity. All right. Questions there? right, let's look at another one. Um, 1 over secant x minus 1 minus 1 over secant x plus 1. And we want to show that that equals 2 cotangent squared x. And I know that there were a couple like this where you worked on this kind of quantity in the homework last time. So I would say it's pretty clear to me that the left-hand side is more complicated. Usually a side with fractions is going to be more complicated than a side without fractions. Fractions give you more stuff to work with. So I'm going to say let's work on the left. So to subtract these two quantities, I need to find a common denominator. So I'm going to multiply this one by secant x plus 1 over secant x plus 1. And I'm going to put parentheses there so I remember to distribute correctly. And this one's going to be a secant x minus 1 over secant x minus 1. Put some parentheses there. All right, so in the numerator, I get a secant x plus 1 minus the quantity secant x minus 1. And in the denominator, my common denominator, I get secant squared x minus 1. Well, in the numerator, I have a secant x minus a secant x, and then so those go away, and a 1 minus negative 1. So I'll get 2 over secant squared x minus 1 from the Pythagorean identity, tangent squared x. And this is 2 cotangent squared x. So I showed that I could work on the left-hand side and get to what we wanted on the right-hand side. Yeah. Yes, you could do it from the right side. It takes quite a bit more work. Yeah.
So we're getting them to equal each other, right?
Well, you're showing that you can work on this and make it equal to that.
So 2 over tangent squared x is equal to 2 cosine.
Right. Right. Uh-huh.
You get 2 on top.
So here I have a secant x minus secant x. So those go away. I have a 1 minus negative 1. The 1 minus negative 1 is 2. All right, let's look at another one. 1 plus cotangent squared x times 1 minus sine squared x. And we want to show that that equals cotangent squared x. Now I would say definitely the left-hand side is more complicated. There's more stuff there. Now we could distribute, we could multiply these out. I kind of don't like that because we end up with a cotangent squared times a sine squared, and that seems like it's going to get messy. But I have 1s and cotangent squared, a 1 and a sine squared. When I see those things together, I should think Pythagorean identity. 1 plus cotangent squared is cosecant squared. 1 minus sine squared, cosine squared. Well, cosecant squared x is 1 over sine squared x times cosine squared x. So I have cosine squared x over sine squared x, which is cotangent squared x. And we got to where we were trying to get. All right, questions there? Sometimes it's not particularly easy to tell which side is the most complicated. All right, so we want to show that secant u plus tangent u equals 1 over secant u minus tangent u. It's not 100% easy to tell which side is more complicated. So when you get one like this, you just have to choose. Which one do you want to work with? Okay, let's work on the right. That's fine. We could work either side on this one. So what I'm going to do for the right side is, because we have more to work with when we have fractions, I'm going to rewrite this in terms of even more fractions. Equals. So when we have fractions, we have more to work with. And the other reason I say that is I look at secant u and I know that's 1 over cosine. And tangent u is sine over cosine. So I have cosines in the denominator. So this is 1 over cosine u minus sine u over cosine u. So I have in the denominator, I have a common denominator. So this is 1 over 1 minus sine u over cosine u. And when I divide by a fraction, it's the same as multiplying by the reciprocal. So that's cosine u over 1 minus sine u. Well, this helps a little bit. Now I'm going to think about, are there, the way this is written, now I know I could write it in terms of fractions. Are there fractions here?
Yeah.
But just the way it's written, are there any fractions there? Secant and tangent? Let's write this so there aren't any fractions. So I'm going to multiply by 1 plus sine u over 1 plus sine u. So I can write it so it's not a fraction. That's our technique if we want to write it so it's not a fraction. So I end up with so this equals cosine u times 1 plus sine u over 1 minus, when I multiply these together, sine squared u. Well, I say a 1 and a sine squared together. That's a good thing. One minus sine squared u is cosine squared u. Well, now I have a common factor of cosine in the numerator and denominator. So I can cancel one of those out. So I did a fair amount of work to go from cosine u over 1 minus sine u to 1 plus sine u over cosine u. But now I just have one denominator. I have a common denominator. I can split those up. 1 over cosine u plus sine u over cosine u, which is 1 over cosine u is secant u plus tangent u. So it's kind of like magic. I look like a magician. The magicians, to me anyway, the magicians that I knew were way weirder than the jugglers.
I'm not calling you weird. I think of like.
And the really weird ones were the guys that blew up balloons.
Oh,
Those
that's
they were a little.
You're like you're a Houdini.
Yeah.
Houdini man.
All right, questions there. If we worked this on the left, I would write everything in terms of sines and cosines, and we would kind of end up in the same place. It's almost like we would end up going in reverse here. We'd kind of go the other direction. All right, let's look at another one. All right, so we want to show that cotangent t, cosine t equals cosecant t minus sine t. Again, hard to tell what which side to work on here. I would say that when you have addition or subtraction, you have a little more to work with than when you have multiplication. So I would work, my suggestion for this one is work on the right. In general, if you have addition, subtraction, you have a little more to work with because we can find common denominators, that kind of thing. So on the right side, I'm going to say cosecant t minus sine t equals 1 over sine t minus sine t. And then I'm going to find a common denominator here because I want to subtract these. So I'm going to multiply this by sine t over sine t. And this is looking good already because I have a 1 minus sine squared t over my common denominator of sine t. One minus sine squared is cosine squared. And I can write that cosine squared t as, so that equals cosine t times cosine t over sine t. And cosine over sine, cotangent t times cosine t. Working on the left side is a little more difficult than working on the right. All right, what will start happening is, like I said, on Friday you'll start being able to see into the future a little bit. You'll say, well, if I do this, then I'll get this, and then I can put that together with that, and you'll start being able to predict how things are going to come out, and whether or not you're taking a good route. But if you don't take a good route and you get stuck, then try something else. All right, let's look at one more. All right, definitely with this one, not easy to tell which side is more complicated. So which side do we want to work on here?
Right side.
Right side has subtraction. Yeah, there's a little. Yeah, that's a good enough reason for me. This one turns out not too bad if you either way that you choose. So I'm going to say 1 minus sine theta over sine theta. I'm going to split this into two fractions because I have a common denominator. So that's 1 over sine theta minus sine theta over sine theta. So I get 1 over sine theta minus 1. Well, what's, let's see, did I do this? Hang on, did I let me make sure I wrote this all down. So 1 over sine theta, what is that? All right, so we have cosecant theta minus 1. Well, what do we want in the denominator over here? 1 plus cosecant theta. So let's multiply by 1 plus cosecant theta. So I get that this equals cosecant minus 1 times 1 plus cosecant is cosecant squared minus 1 over cosecant theta plus 1, or 1 plus cosecant theta. Well, what's cosecant squared theta minus 1? Cotangent squared theta over 1 plus cosecant theta. So sometimes you do this to write it so it's not a fraction. This time we did that technique to write it so that it is a fraction. And we chose that because the denominator of the fraction we wanted was 1 plus cosecant theta. If you work on the left side, really you go kind of in reverse. I would write this cotangent squared theta as cosecant squared theta minus 1, and then you would factor. All right, questions? Yes?
So, like, if you had to say, like, if you had to say one thing to help us figure out like, how to get there, what
Just try something.
trial and error.
Yeah.